the name of the topic is the transport layer. So now, if you again recall the TCP/IP model, the lowest was the physical layer, then you have the data link layer, then you have the network layer, then you have the transport layer, and right. So what is basically the content that I'm going to cover? So what is the need of the transport layer? What are the functionalities or the responsibilities of the transport layer? Right. So there are basically 5 main functionalities that you can think of. It's a true end-to-end layer. I will explain you why. It provides the port addresses. It does error control and flow control. But now, I'm not going to discuss this error control and flow control. The reason is whatever the error control and flow control mechanism you learn for the data link layer, the same mechanism is applicable here. Right? Only the difference is data link layer used to do the error control and flow control from hop to hop. Let's say a source to switch 1, switch 1 to switch 2, switch 2 to switch 3, like that. Data link layer. Whereas transport layer will do the error control and flow control from source to the destination. What I mean by source to the destination, suppose you are writing an email to somebody from Yahoo to Gmail, then your Yahoo is your client and it goes to the Yahoo server, and then from Yahoo server it goes to the Google server, and that's how the email gets delivered, right? So when I say you are a client, Yahoo using Yahoo client, and your server could be Yahoo server, so this client to server, right, or whatever the live communication is happening between client and server. So that's what I mean by the source and the destination. Right? We are not dealing with intermediate router or intermediate switches. So that is what the functionality of transport layer. It does the error control and flow control between the source and the destination. Otherwise, the same principle applicable what you have studied at the data link layer. Data transmission between processes to processes. Segmentation we will understand. Then there is something called a UDP, which is called User Datagram Protocol, a very famous protocol at transport layer. And then you have a TCP, which is Transmission Control Protocol. I expect all of you to write not a transfer control protocol, it's a transmission control protocol, right? So now someone can ask me a question here, what is the need of a transport layer? See, for example, if I open multiple browser instances on my machine, in one instance, I am using Yahoo. On another instance of the browser, I am using Gmail. Now, believe me, for my Yahoo server and for my Gmail server, when they are sending back the traffic to me, my IP address will be same for both. Only the difference is from when it comes to the transport layer. So basically, your transport layer is required to do the delivery from a process to process. You already studied in operating system, when you run any program and the program when in execution, we call it process. If I double click on the browser instance, that means I have started a browser instance. It's running now. Then it's a process that I have created. So whenever a process gets created, it's getting a process ID in the operating system. Similarly, in the networking concept also, each process has a unique ID. And that unique ID is nothing but a port address actually, right? So when the IP address is same, and when it comes to the process delivery, it would be differentiated by the port addresses. So actually, in order to have a process to process delivery, you need a transport layer, right? So let me explain you the concept. So look at this diagram. This is quite self-explanatory diagram. Still, I'm trying to explain you. If you look at these 3 nodes, node to node, host to host, and process to process. Who will do the data delivery from node to node? It's done by the data link layer. You can see here in this diagram. This is the node. This is your machine. From route to router 1, router 1 to router 2, router 2 to router 3, router 3 to router 4. ये node to node जो लिखा हुआ है, ये कौन कर रहा है? Data link layer. This is the job of the data link layer. Now host to host. Look at this. This is your source machine, this is your destination machine. Who will do that? Host to host network layer based on your IP address. And when it comes to on each host, I could have multiple processes. As I said, friends, I have a 2 instance of the browser. Let's say this is one instance, this is another instance. Then who will correlate the process to process communication? It's a transport layer. So process to process communication is done by the transport layer, and that's how it's needed actually. Because if your packet will just reach from source to destination, it's not sufficient. it has to be delivered to the appropriate process, and that job is done by the transport layer, and that's actually the need of the transport layer. Basically, a transport layer gives you the port numbers. So whenever you open a new instance of a browser, or you start a messenger, or any net applications which require an internet, or any applications, right? You are creating a specific port number actually. So in this diagram, there is an example of a daytime server and daytime client. It's my favorite example. Let me give you again. I don't know how many of you know, but earlier days when I was at Roorkee, I remembered 2003 to 2005. Railway reservation window will remain open only up to 2 p.m. और संडे को 2 बजे रिजर्वेशन विंडो जो रेलवे का रहता था वहां पे हमारे कैंपस में था, यूज टू गेट क्लोज एट 2 o'clock sharp. And so if somebody is late by 1 minute or 2 minutes, then the people used to argue with that clerical staff कि भाई अभी तो 1 मिनट की वार है, why you are not issuing the ticket. At that time, what that fellow used to reply is, see, my server is stopped, it will not accept. So now, see, how we can omit such kind of arguments? So server was taking the time from where everybody will accept. Otherwise, तो वो क्या करता, अगर क्लार्क को घर जाना है जल्दी 1:30 बजे, उसको घर से किसी का फोन आया and he wants to go early, what he can do probably, he can change his system clock, so that reservation get closed. But that's not it. That's not how it works, right? So there is a standard server available, authorized server, from where you can take the time. So for example, when you do some e-transaction, right, it has a timestamp. Now from where it's getting the time? It's not a server of the bank manager, right? It's a daytime server, and daytime server service is running on a well-known port number 13, Tera number, lucky number, right? So this is what you mean by daytime server, and this is a daytime client. Now client can request from any port number. How to get this port number 52,000? What could be the maximum range? I'm going to tell you in 1 minute. So just keep a hold on that. But this is how the data is transferred. So here is the data. Here is the destination port 13. Here is a source port. And then when the reply comes, it's again the data. It's a source port and it is the destination port. And this is what I'm trying to show you. There are multiple processes here, but how the daytime client and daytime server have been synchronized in the communication by means of port addresses or port numbers. I hope the idea is very clear now, right? Let me go ahead, guys. So let's say the difference. What is the difference between the IP address and the port numbers? As I said, port number select the process, whereas your IP address select the host. So this is the host, right? So host तक जो पैकेट को लेके आने का काम है वो कौन करेगा? That will be done by the IP address. और process तक लेके जाने का काम कौन करेगा? Port number, right? So this concept is I have seen in so many movies. Whether you talk about Baby or any movie, action movie, So that Akshay Kumar will travel to a specific city and then there is a common agent there or common support is there who will take you to the specific place. So I always try to correlate this, this guy is an IP address and this guy is the port address, like that. So you can do the same thing, right? So this is how it, now look at this is very important diagram. There is something called INA. I wish all of you to do a Google search and find out what is this INA. Right, it's one of the recognized agency which dealing with a lot of things, but I wish you to explore it. I'm not going to tell you now. Now, very important thing, friends, for a port address, your length of the port address field is 16 bit. That means you can give a port address using 16 bits. And now if I have a 16 bits, what is the minimum value possible? If I set all the 16 bits to 0, I will get 0 in decimal. And if I set all the 16 bits to 1, I will get 65535. अगर 16 bits में मैं सारे bits को 0 कर दूंगा, तो मुझे जो minimum decimal values मिलेगा वो 0 मिलेगा, right? And if I set all the bits to 1, what I'm going to get is the 65535. So when I say 65535, actually, so this is the range because your port address could be indicated by 16 bits. So its value range from 0 to 65535. ये आपके पोर्ट एड्रेस की रेंज है। इसका मतलब एक बार 65535 खत्म हो गए उसके बाद मेरे पास पोर्ट नंबर नहीं होंगे। इसका मतलब अगर आप ब्राउजर के इंस्टेंस 65535 से ज्यादा क्रिएट करोगे तो उसको यूनिक पोर्ट नंबर नहीं मिलेगा। You want to do that experiment, write a program either in C or a Python. Let's say that program keep opening the instance of the browser. If you are writing in a C programming, take a long integer variable and open more than 65535 and see what is happening to your machine. Out of this 0 to 65535, the port number up to 1023, starting from 0 to 1023 is called well-known ports. ये 0 to 1023 के जितने भी पोर्ट नंबर है ना, दे आर रिजर्व्ड। दैट मीन्स इन माई एनी कस्टम प्रोग्राम और एनी यूजर प्रोग्राम, I do not have a luxury to use the port number from 0 to 1023. Now, it does not mean that you write a program and you cannot use it. You can use it, but that program will work in your local machine. For example, if you try to use the port number 13, the program will work on your internet. Because you don't have that luxury. Otherwise, what will happen? There is a confusion. Rather than getting a request on the time server, somebody will start sending the request on your machine, and that's how you can do the hacking. So you don't have on your local machine, if it is not connected to internet, you can do that. But otherwise, you cannot use the port number starting from 0 to 1023, right? Because these are the reserved port. That means whenever you open an instance of the browser, your operating system will also give you the port number which is starting from 1024 to 65535. So I already said about the port number. What is the length of the port number field? Length of the port address is 16-bit. Now please understand, your IP address will take you to the host. Port address will take you to the process. If I combine the port number and the IP address, what I'm getting is called the socket address. So there is a concept of the socket address. See, in a domain of a computer network, there is an entire subject which is called the network programming, right? So whether you are using a Google Chat or a Hangout or any kind of communication, two-way communication application, actually the concept was started from the socket programming. Right, so there is a concept of a socket address. So what is the socket address? It's a combination of IP address and the port number. If I combine the IP address and the port number, I'm getting the unique key. I'm getting a primary key, and that primary key is actually called the socket address. Right, the length of your physical address or the MAC address is also 48 bits, and the length of the socket address is also the 48 bits. So socket is basically a primary key in terms of databases. You can think of a primary key, right? It's a primary entity for a communication. So socket will uniquely identify a communication channel. Please remember, socket used to identify uniquely a communication channel between the source and the destination, right? Socket is the combination of IP address and the port address. Another important functionality of the network transport layer is the multiplexing and the demultiplexing. देखिए यहाँ पे on the source side, I have multiple processes and I have multiplexer. So what your transport layer will do, it will combine all these streams into one, and then it can be transferred on the IP. And then again here it does the demultiplexing. So here it's a many-to-one relationship between process and transport layer protocol at sender, and here it is a one-to-many relationship between the process and the transport layer protocol at the receiver. So this is how you have to understand it, the difference. Right now, I have two protocols at the transport layer. So naturally, you could have a question here: why there are two protocols? And if there are two protocols, what is the difference? So one is the TCP, another one is the UDP. TCP का full form है Transmission Control Protocol. UDP का full form है User Datagram Protocol. Right? TCP is basically a connection-oriented protocol, whereas UDP is connection-less protocol. When I say connection-oriented, what it will do, before you transfer the data, it will establish a connection. Before you transfer the data, it will establish a connection. How we gonna learn? Don't worry. Right? Data are numbered. That means that each segment has a number and it has an acknowledgement also in TCP. UDP will not establish a connection. It will just throw the packet. It will just throw the packet and deliver the goal. Chala jayega, like that. Right? There are no acknowledgements in the UDP. packets or segments may arrive out of order. It get delayed, it get lost. UDP does not care. Does not care. TCP is a byte-oriented protocol, where the UDP is a message-oriented protocol. Pink line indicates the error control is done by the data link layer. See, in this diagram, the pink line indicates error checked in this path by the data link layer, and the black line indicates error is not checked in this path by the data link layer. तो अगर data link layer मेरा error checking यहाँ तक ही करता है, ये जो पिंक लाइन है ना वहीं तक, ये छूट जाता है, ये ब्लैक लाइन वाला पोर्शन, ये ब्लैक लाइन वाला पोर्शन छूट जाता है, ये ब्लैक लाइन वाला पोर्शन छूट जाता है. दिस इज नॉट डन, एंड दैट्स द रीजन you need to put an error control in the transport layer. Otherwise, as per the software engineering principle, there is no point in repeating the functionality what is done by the lower layer in the upper layer. But the reason to have error control with the transport layer is to take care if any error is here after the data link layer, here on the network layer, here on the network layer, or after the data link layer here, then who will take care? And that care will be taken by the transport layer. That's the reason we have an error control at the data link layer as well as at the transport layer. I hope it's clear now. There is something called a user datagram protocol. It is called a connectionless unreliable transfer protocol. Very good word. See, about UDP, it's unreliable. Now you should ask me a question. See, why somebody wants to use the unreliable protocol? People does not have a friendship even with somebody who is unreliable. Then why we have a protocol which is unreliable? Believe me, it is the need of an application. It is the need of an application. You need to use that unreliability at your advantage. It does not add anything to the services of IP. वो जो IP जो provide करता है ना, वहीं पे उसने एक UDP लगा दिया, except to provide a process to process communication instead of host to host communication. IP और UDP में एक ही difference है, IP host to host data लेके जाता है, UDP उसका just addition है कि उसने क्या कर दिया, process to process communication कर दिया, बाकी जो IP कर रहा है वही UDP कर रहा है. That is only the reason why UDP is very simple in the design. It has no flow control, it has no error control, it has no acknowledgement, nothing. Very simple protocol. Now you can ask me a question, see what kind of applications I need to use the UDP protocol. See, one of the straightforward answer is when we are doing live streaming or where we are broadcasting a live, for example, live match, right? Or any entertainment program, probably the UDP could be the best choice. The reason is, in TCP what will happen is whenever the segment gets lost, it does the retransmission. अब आप सोचो कि एक फाइट चल रही है, उसमें एक फाइट में या तो एक मैच चल रहा है, एक प्लेयर ने 6 लगाया, अभी दूसरा बॉल भी शुरू हो गया है, उसका वो 6 वाला एक दो फ्रेम बीच में आ जाए तो कितना कंफ्यूजन हो जाएगा कि ये 6 लगा या बोल्ड हुआ या क्या हो गया, right? So for those kind of applications you don't require really a retransmission to happen, and that's where UDP came to a service. Its simple design has made it so popular. Sometimes, you know, simple things will work very well rather than complicated things. So follow that principle whenever possible. These are the well-known ports used with the UDP and well-known services like echo, discard, user, daytime. I already explained you got name server, BOOTP, TFTP, RPC, NTP, SNMP, right? SNMP. There are 2 variants. One is 161, another one is 162. So these are the very well-known port numbers. So somebody can ask you, echo service run on which port? It's 7. Daytime service on which port? 13. Like that. Would be on 67. Name server, DNS on port number 53. DNS. Right? TFTP. It's not FTP. TFTP. It's 69. Right? So these are the some well-known ports, and you can see all the well-known ports must be below 1023. ये 1023 से कम ही होंगे. That I already explained to you guys. Right? This is the format of your user datagram, header actually. So whenever we are using UDP, I have a data which is coming from my net, application layer, and then I'm adding the header, UDP header. So what is the length of the UDP header? header length of the is 8 bytes. See this one, there are 2 rows in the UDP header. The length of each row is 32 bits. So when I say 32 bits, it's 4 bytes. When it's 32 bits, it's 4 bytes, right? And again here we have 4 bytes, right? So source port number 16 bits, destination port number 16 bits, right? Source port number 16 bits, destination port number 16 bits, right? And total length is 16 bits, checksum is 16 bits. So source port I already explained to you, destination port I already explained to you, total length, right? What is the length of the entire packet? And this is the checksum, 16 bits. So that is just to detect header error. TCP is a transmission control protocol. TCP is a connection oriented protocol. It creates a virtual connection between two TCP to send the data. In addition, TCP uses flow and error control mechanism at the transport level. We will go in the detail in the next week